Hello, so let's continue on our project. So in this video, I will explain how to create a concrete schedule. For this purpose, let's open Sheetset Manager on AutoCAD web version. Architecture drawings, schedules. So concrete schedule will be organized and created in schedules. So the purpose of schedules is the same like views. So it is specific DVG file for the schedule location. And later schedule will be placed in the specific sheet for the schedules in this location. So these files are created in Sheetset Manager. So I can open these files using AutoCAD. In AutoCAD, I will go also to my project and open the Sheetset Manager from here. As we discussed in previous video, after update, Sheetset Manager web version was replaced by default Sheetset Manager for the projects which are located in the web, in the Autodesk Desktop, Autodesk Construction Cloud in the web. So in this, I cannot do any management, so I cannot create new stuff. So if I want to manage that version of Sheetset Manager, I need to go to Sheetset Manager in AutoCAD, that version of the AutoCAD. So it's similar like with Word documents. That version has some limitations on specific tools, and desktop version has more functions and features. So for specific tasks, I recommend to use desktop version. It runs faster and has more features. But if you don't have installed AutoCAD version on your machine, or you are using different machine, so you can reach out all your files using AutoCAD web version on any device, on the tablet, on the phone, on the laptop, computer, and so on, and easy modify and change the drawings. So you don't need installed version of application. So now I will open this concrete schedule. So I don't need this attached image. I will detach it. Also, in this drawing, I don't need any layout or any sheets here, so all my work will be done on model space, in model space. And before I start, I would like to see my coordinates. So I would like to see my user coordinate system, location of YX, and I also would like to see the grid line. So next step is to insert needed information, so I can later check results. So to insert information, I will attach a PDF file from here, from Elements, in my homework number 4. And for this one, I don't need to convert it to vectorial drawing, so I will turn off vector geometry, through type text, and use PDF layout. Okay, join lines, So I just need information, so I see all the data inside one specific drawing. And now I can click specify at least one type of PDF data to import. Okay, so I just import raster image. It located raster objects and just raster image. Okay. So TrueType text. Okay, so solid fills. Okay, so just vector geometry, TrueType text. And I will import it as a block. Yep, maybe. Yep, and I don't have text. Okay, so I'm just having the lines. Also, this one is not suitable, so let's try again. So I need text, and let's import it with this information. So here is my reference for my building. So I need to calculate and get these volumes in my schedule, and I need to create this schedule for my project. So I will move to the side this reference drawing. I just grabbed this blue square and will activate F8 for perpendicular move, and let's move it to the side. So now you can see the table is organized above title block, so it means the length of this table is in specific dimensions. If I use distance tool, I can measure this distance, and the scale of this drawing is not accurate. So basically the length of the weight of this table should be the same like title block. So in the drawing we have 10 millimeters on one side, 20 millimeters on another side. In total it's 210. So minus 30, we get length of this part is 180. So to see this information, you can check Planary in our class material. And here we have our title page, schedules, title blocks. So here is dimensions, as I spoke, it's 180 millimeters. So this is size of title block, and the spacing and the size of each row is increment of 5 millimeters. So 5 millimeters, 10 millimeters, 15 millimeters, and to the both sides, vertically and horizontally, increment is 5 millimeters, and we will draw similar table also in here. So to do and to draw the table, basic rules, we have specific lines, specific layer for these lines. Next we have text. Text is two types of the text. Title name of the table is 3.5 millimeters, and the internal part of the table, so the header is 2.5 millimeters, and body text is also 2.5 millimeters. So all style of the text is ISO style of the text, and in here we have several columns. So we have marking. The mark represents the object. So links object to the schedule. So if I want to locate wall information, so in this project I have 12 objects representing this kind of wall, which is concrete, high density, and volume of these walls is 30 metric cube. Next one, column represents the standard of materials. So this is international standard, represents basic material types. Next one is description of materials. So we have high density concrete, 2,400 kilograms into metric cube, and here we have specific information of thermal parameters. Model of this material object is not defined. So standard and description is called name and technical characteristics according to Lithuanian standard. So Lithuanian standard information, you can find some details in this class material, schedule table standard, and in here you can see all specific fields of the tables. So here we have tables for the sheet lists, and here we have concrete schedule information, mark, name and technical characteristics, model, count units, abbreviations, and notes or comments. And here you can see example. Next one, count, how many objects are in the project, volume, total volume, and the comments to represent some details, and total quantity of units and total quantity of material. So now creating the table can be done in a couple of ways. I can just go and just use line tool and just draw lines, vertical and horizontal lines, and create the table by doing that. But in AutoCAD we have dedicated tools to create such objects. So I should go to annotate and look for the table section. And these tables are quite smart. They can be linked to Excel spreadsheet. They can recognize some basic formulas, and also it's organized like a table. So in university template, we have a couple of templates here. So we have template which has associative size of table. In our case, we don't need to do associative size, so practically we can create the table scale 1 to 1. So now I have a scale 1 to 2, scale 1 to 50, annotative scale, and in this case I should manage the template and make a copy of this one. So let's create new, and the scale will be 1 to 1. Continue. And in here I can organize the details. General, select table to start from, table direction down, okay. Data, so cell style for the data. General information, I can select what kind of color, middle center, format, general, so specific format for the data. So data you can see here, and type is data. Horizontal, vertical margins 0. Merge cells on row columns creation. No, in this case let's make separate. If I create merge, so it creates one large part. So text will be 2.5 scale 1:1. Text color by block. Let's do it by layer. Here by layer. Fill color, no, we don't need any fill color. Data type, alignment, middle center. This is in center, middle center. So all markings and numbers should be in the middle center, and text descriptions should go and be aligned to the left side in middle left. But in this case I can organize just full information of all the table. So lunches, we create new cell style dialog box. Maybe I can separate it to different columns and specify specific style for each column. But in this case, let's use simplified version. Okay, so text I changed a little bit, and borders by layer, double lines. Okay, I don't need any double lines here. And okay, so data part is done. Header, so header is here, and middle center, label, okay. Text size, text is scale 1:1, and by layer, and borders by layer, and the color by layer. So this part is done, and the title, middle center, okay, label. So in this case I want to merge everything, so it should be one self to represent the title. Scale should be 3.5 1:1. I have 3.5 1:2, 3.5 1:1. Yes, so this will be the size, and by layer, and here is by layer. And the title should not have any lines on the top, on the sides, only on the bottom. So only the table should be with lines, and the top and the sides should be without lines for the title. Now the style is created, and I will make it current, so it's main style which I am using in my project. Now let's see what are the functions and features here. So now my main style is selected. If I will click this one, I will create an empty table object. Next one, I can extract the data, extract drawing data, and merge data from an external source to a data extraction table or external file. Next one, download from the source, updates linked data from external data file to a table in the current drawing. Upload to the source, updates linked data from the table in the current drawing to an external data file. And linked data displays the data link manager. So if I want, I can link information to Excel. All the numbers in text is of course, more convenient to manage and organize in Excel spreadsheet. It's not so easy to do in AutoCAD. So I recommend to use dedicated linking for the tables. But in this case, if you link and make a link with a specific Excel spreadsheet, so if you share your drawing or send the drawing, you always need to attach also Excel file, because in our case, table will lost the link, and sometimes the information can be also be lost. So let's begin and let's create the table. So in table creation manager, insert option, start from empty table. Okay, I don't have any data from Excel now. From object, data in the drawing, data extraction, I also don't have such one, and preview, I can see how this will look in my project. Now specify insertion point. I will specify insertion point, of course. Specify window. Yeah, I will use this option. So how many columns? 1, 2, 3, 4, 5, 6, 7 columns. Column weight should be, as I mentioned, increment of 5 millimeters. So I cannot measure this part. So let's check maybe in here. Typical distance. So the scale of this one, format scale, will be 1 millimeter to 1 millimeter. Yeah, so now the scale is correct. So practically all these columns is 20 millimeters. Other columns, this one is 15. These are larger ones, and columns are also larger one. So column weight, let's set 20 millimeters. Data rows, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 rows, and row height should be lines. So it's measured by lines. Not sure. 1 line. Specify the height of the rows in number of lines. The height of a line is based on the text height and the cell margin, which are both set in the table style. When the specify window option is selected and you specify the number of rows, the auto option is selected and the row height is controlled by the height of the table. Row height, data row, columns, specify window, data row 16. So these will be automatically calculated. So maybe this option. First row cell style title, second row is header, all other rows is data. Okay, let's try. Whoa, Okay, it looks quite big, and here we have 180. So table is quite big. I will place it in, let's move it and place it inside 0, 0. And 0, 0, 0. So the scale of this block is quite small, and I can increase the scale. So let's change the scale, and I know reference, so this point will be this one, and I will use reference. So from this point to this point, I know it's 180. And now I have real size of my table. So let's now fill the information in this table. So first let's start from the title name. Concrete schedule. Next one is marking. So marking should be date 15 millimeters. And the height should be 5, and I see, so let's make it 10 millimeters. And the content, let's type mark. Let's go to the next one. So next one is let's measure it on PDF file. So this one is 15, this is 30, this one is 45, this is 20, 20, and the last one is 13. So this one is 30, and the name is these should be merged. Okay, so I will do it later. So next one is 45, 45. This one is 20. So this one is model. Next one is 20 also, and here we have count. Venti, and this one is volume. To clarify information, so total volume, because it's calculated total volume, and next one is comments 30. And the size of this one, so we have 5 millimeters, 10 millimeters, so it's related to text size 2.5 millimeters, so double the text size is 5 millimeters. For the title name we have 3.5 millimeters, so double the size should be 7 millimeters. and if size is double, so it should be 14 millimeters. Let's try with 7 millimeters. I think 7 millimeters is enough. And here I will merge these two cells. So I have specific option here, merge all, merge by row, merge by column. So I want to merge these two cells. Merge. Merge all cells in table. Merge by row. Okay, so now it's merged, and the name will be name and technical characteristics. And also I need to define a specific layer for my table. Let's check in printed version. So the table, it's doors details. Yeah, so it's defined as architecture details. And the text area. General schedule. So general schedule is the text, and architecture details thin line. Okay. So all the table belongs to architecture details thin. So by layer, thickness by layer. Okay. Position, great. And now the text. Content, text style, text size, text rotation, text color, data type text. So for the text by block, so instead of this one, I will use general shadows layer. So general shadows layer for all the shadow. If I am using table, so I see it's maybe not possible to specify specific layer for by layer. I can change color manually, yes, but can I define different layer for the text? No, I don't have this option. So it means it's all the information is linked to one. And the last column will represent the total. So I don't need any I don't need some borders here. So edit borders. So in this below one, I don't need borders, these borders and these borders. I don't need them. I just need the top borderline. Okay. Okay, so and now I need to fill the data. I can see the size of the cell will be 10 millimeters. So if I have 15 here, so the size will be 15 multiplied by 10 millimeters, it's 150. Apply. Whoa, no, so it means 10 millimeters. Yeah. And the last one will be 5 millimeters. So now size is correctly defined, and now I need to fill the information table. I move it up to 0, 0, 0. So from creating the table, I see if I change something, everything goes down. So in the template, I set this parameter to go down. So maybe for some tables, it's a good practice to set it going up. So it means it goes from bottom part to up. But in this case, the title and header also is located in the bottom part. So yeah, so this option is not suitable. So the template should be down. So in such case, you need to take into consideration because the table goes down. So I can attach it maybe to this point, and it will be constant point here, located on 0, 0, and all the information will go down. Okay, in any case, let's continue. So now let's fill information in the marking area. So in here will be C1 for the column. Next one is CF1, FLT1, FLT2, FO1, BF1, ROT1, ROT2, ST, ST1, ST2, Volt T1, and Volt T2. Maybe I lost something. C1, C1, F, F, E. Okay, I see 2 rows is not needed, so I will delete these 2 rows, and the last one is total. And all these rows have the same information. So European ISO standard 10456 for basic materials. Next one is the name of the material. So it should be high density concrete. (2,400 kilograms in metric cubic), and this so to change position of this one, I can in this case I will need to use a specific tool. So it's character map. So this is Windows specific character map, and here I can see a representation of cubic. I select the object, copy it, and copy paste it here, and it creates this symbol 20 and 00 00 W and K. And for the specific dot, middle dot, let's use this one. Yeah. So information is nicely filled, and as I mentioned, I can align these to middle left. Next one is the model. So the model is, I don't have a specific model for this material, so it's no information. Now regarding counting, so I have one column. Here is one, and all these should be into middle center aligned. Okay. Here is one. Here we have, okay, one. Foundation 5, PF is 1. RO is 2. So all these markings are also located in this schematic view. In this image, you can see all the markings of each object, and by looking to this schematic view, you can see all the parameters: wall, foundation, column foundation, and floor, roof. I have roof 1, and this small roof is roof 2. And from here you can identify which objects is mentioned in this location. the stairs. It's 5, 1, 1, and I have 12 walls and 2 walls here. And let's align everything to this location. And roof 2 is 1. And also don't forget to save your progress after a couple of modifications. Next, I want to calculate volume, so I can enter volume numbers from this table. In my case, I also would like to use formula, and I would like to calculate the volume. So how to do that? I can use a formula field and begin calculations. So first I will calculate here the sum of all the counts. So sum, let's enter sum here. And let's click enter. Okay, so maybe I made a mistake summing all these numbers. So I have 34, in here I have 35, so something I am missing here. So 1, 1. Yeah, so I don't have one object here. What I missed? So the beam. Okay, so I missed additional row. Let's insert additional row, insert above, and this will be B1 for the beam. And I will copy all these columns and just copy paste on here. And the information is copied to this location. And I need to fix the formula. And to do that, so I will change it to number 3. And now I have 35. So now it's calculated. Next one, I need to calculate the quantities of specific elements. So if I go to this schematic representation, so I can see here is my column, here is my beam, specific size of walls, and to calculate all these volumes, I need to have information about each of the element. So to do that, I can see some information inside my drawing. For example, I have parameters of this roof part here. So this one is 2.2 meters, and 1.3 meters 30 millimeters, and thickness is 150. So let's say for the roof type, this one, I can type in a specific formula, equation equals, so let's see, 100, and it's in meters. Okay, so 1.330 multiplied by 0.150 and multiply by 200. And here I have the volume of this roof, and it's 0.44. In here I have 4 decimals after the point, so I can change some parameters here. And data format will be decimal number, okay, and I would like to change customize table cell format, decimal number. Decimal current units, decimal. Precision. So precision will be 2 digits after comma. Now I have the same number here. So the same rules go here. So this will be also decimal number. And format decimal, and precision will be also 2 numbers. And it will be the sum of all parts above. So I have specific formula. So it's the same like in Excel. I have letters representing the columns and numbers representing the rows. And I type the basic functions, and I can type here, and it calculates automatically. So next, the beam. So the beam size. So the beam size we can calculate from information what we have here. The length of the beam is on the top of the column. So the length of the beam is 2.7 meters plus 400 millimeters. Thickness is 200 millimeters, and the height of the beam, from this drawing I cannot tell. So let's check it on the schematic view. In here, I also don't have the data of this beam. So looking to the proportions, the height of the beam is the same as the column. So my column is 400, so the height of the beam also will be 400. So let's write the formula, equation. So in the brackets I will type the length, 2.7 meters, 0, plus 400 millimeters, 0.4. I will multiply by 0.2 and multiply by 0.4. And and I have the size to 0.25. 0.26 is here. So the beam is also inside, or is on the wall, so it means the length of the beam is extended by 200 millimeters here. So let's change the formula, the field. So additionally, I need to plus 0.2 the thickness of the wall. Okay, so here we have 0.26. So practically I have my wall here, and I have my column here, and the beam is on the wall and on the column. So it's putting the load on this location, and also putting the load on my column. So the load goes down to the foundations. So next one is the column size. So regarding column, so I have basic dimensions of the column, and the length of the column, it goes to the line of foundation. So I need to go to the section view, and the distance from here to this foundation part. So here we have 3 meters, and to the foundation we have 850 millimeters. So I need to put in minus 200, thickness of the beam 400, and I should get my size of my height of my column. So let's try to enter all these details in the formula. So 3 meters plus 0.85 minus 0.200 minus 0.400, and yeah, so it will be the height. So thickness is 0.2, and weight will be 0.4. So you can see I got 26, 0.26, so the same size is here. Precision 2 digits. And here you can see it's calculating all the quantities. Next one is CF1. So size and dimensions of column foundation, and we don't have a lot of information about column foundation, so let's just enter the number from here. So column foundation will be 0.86. So you can see if I enter the number, somehow all the presets of this cell is changed, and I need to change back all the format settings and enter all the data again. So it's not so user friendly, and I need to repeat some steps which I done for these cells. But yeah, it works like that. So next one is floor of the first floor and second floor. So to calculate the floor size, I need to do some mathematics. So it means I need to calculate area of this part, and also I need to remove the size of the column from my floors. So the formula will be like this one: equation. So let's calculate information we have here. So the length and the weight is located here. So .4 meters multiplied by 6.2 meters and multiplied by thickness of the floor is 0.2. Now from this I want to remove the volume of my opening for the column minus, so the opening for the column will be 0.4 multiply 0.2 and multiply by 0.2. Let's click enter. 916, and we have 916 here. Okay, so this number is correct. Next, second floor height and volume. So I need to remove the size of my staircase from the floors above. So practically I can start the same formula equals. So let's calculate total volume multiplied by 6.2 multiplied by 0.2. Now let's remove opening for the staircase. So staircase opening, so thickness is the same, 0.2 multiply. Now I need to have the distance from this point to this point. Do I have this distance? Yeah, it looks like it's here. So the distance is so I need to put additional brackets. So 3 meters plus 1 meter point 3 and plus so here we have 30 millimeters and 200. So plus 0.03 and plus 0.2 for the wall thickness, and this distance and let's multiply, and now let's calculate this part. So it's 2.9 meters plus 100 millimeters. Opening starts and is in this location, and I think I need to remove also this wall, or maybe not. I think the floor is in here, a wall, and wall is, yeah. So I just need to remove just the opening part. So 2.9 meters minus 100 millimeters. So 2.9 minus 0.1. And in here I need to change remove the thickness of the wall. And let's see what number we have. 6.75. 6.75. Yes. So this part is calculated correctly. Now regarding foundations. So foundations are located below the walls. So I need to have the perimeter of the walls. And I need to calculate the foundations. So first I can calculate area of foundations, and later I can try to multiply it by perimeter. And in foundations I have 5 parts. So 4 foundation elements below external walls and 1 below internal wall. So the same you can see here. So I have foundations below external walls, and I have additional foundation here below internal wall. So this part can be quite tricky to calculate, but let's try. So as I mentioned, let's first calculate area of foundation. So the area will be 0.305 multiply the 0.457 by 2. So this is area of foundation. Let's multiply it by the perimeter of foundation. So the perimeter will be 7.4 minus 100. Okay, so the perimeter will be I have 6 meters here, and I have 7. So in formulas, it's best to write all the numbers. So let's type 3 meters plus 4.2 meters plus 6 meters plus 6 meters plus 3.0 plus 4.2. So I can see the same numbers in here. If I do some calculations in calculator or in my head, and later it's difficult to link the specific numbers to the drawing. So all the information should be taken from the drawings. If I cannot calculate quantities from the drawing, so it means it's not fully prepared, and I need to provide additional dimensions in my drawing so I can see all the needed dimensions, and from dimensions I can calculate all needed quantities of my building. Okay, and internal perimeter of this part is this. So I need to put plus 0.32 plus 0.9 plus 1.48. And sometimes it's good practice if you think about quantities to put extra dimensions which can help to calculate the quantities. In our case, I need to do all these calculations maybe manually. Of course, if I am using and creating 3D model or creating the BIM project, all of these calculations, it's not a big issue because the program is calculating all the quantities from 3D model. If I have 2D drawings, so this calculation can take some time. Also, I have a quite large foundation here, so it means my perimeter of my wall is not completely ending at the edge of my column. If I go back to this schematic view, I have this additional space here. And this size, I think it's the same like here. Mm, 357. I think I put it 200 for this one, so it means in the schematic representation we don't have enough information. So I will just remove 0.2 meters. So here I have area of my foundation and preliminary perimeter of my foundation. And let's see what number I will get. 805, 7.93. So it means my perimeter is too big and I got too much. If I go here to schematic representation, so I think I need to remove this part also, because this segment will duplicate information. So let's remove from axis grid line A to the side of foundation. And let's see from here. So it's 457. Okay, let's remove 0.457, 7.92, 793, 793. Yep, it should be correct. So if I change precision to two numbers, 793, 793. Now, yeah. So the logic is like that. So from these formulas, you should see and understand how it's important to have all needed dimensions. Now I am making some assumptions about size of my column foundation and additional assumptions about other objects. But in your project, if you are creating the project, so always think how the quantities can be calculated, and from this you can identify how many dimensions and information you need to show in your main drawings. So next one, PF1. So PF1. Here's PF1, PF1. PF1, foundation 1, so column foundation, roof, PF1, PF1. It's a pile foundation. Here we have additional object, a pile. So in schematic view, we don't have information about pile foundation. So let's enter this number 1.74. 1.74. And let's change decimal units. Precision is 2 digits and alignment is center. Next one, roof. So this is calculation of this roof part. So here we have two segments, one segment for one side and another segment for another side. So to calculate this information, I can open and see the area of my hatch. So to do that, I will link and attach section view. So section view is, I think, this one, 0201. And I will double tap on this one so I can edit it in here. Let's click home. I don't need to see this. And from here, I can select this one. And here I have area of this hatch. So this hatch is representing area of my roof. So let's grab this calculation and let's use it later. So now I can copy it, close. I will close hatch editor, and also I will discard the changes and go back to my drawing. And I will turn off this drawing detach or unload. Yeah, let's unload it. And next parameter is the length of all the roof. Okay, so I have area of my roof equals. So area of my roof, let's Control V. So it's in millimeters. And I need to multiply it by length of my roof. So the length of the roof will be 7.4 plus 0.5 plus 0.5. So this part is in meters. So AutoCAD is not a clever application, and it cannot change or recognize dimension units. In Revit you can write in meters and millimeters, and it automatically calculates. In AutoCAD you need to do it manually and to change parameters here. So in this case, I will need to multiply by 0.001 and maybe additional 2 zeros. Okay, let's try it like this one. Okay, 30.003. 30.03. Yeah. So each time I am doing any manual calculations, changing units, it's always a possibility to create a mistake and make an error. And it's best option if all these calculations are done automatically from the data which you create inside the model. So if the program can recognize all the walls, all the elements, and calculate all these parameters automatically, like in BIM projects, they can calculate volume and quantities of material automatically, so you can avoid mistakes. In AutoCAD, you can make a lot of mistakes, and dimensions and sizes can have some problems. And now I'm doing calculations manually. So as you remember, when I was doing this detail, I found micro mistake here and tried to modify the hatch and so on. And all these small mistakes are not represented in this table. So it means the data which I am entering here is not linked to the data what is inside my real drawing. If I make mistake and I just show nice dimensions here with specific precision, I can create an error and a mistake. And on small scale building, it's maybe not so a big problem, but if the building is large and the mistake is repeating in all the parts of the building, and it can multiply to quite large quantities, which can lead to a big problem in the project. Okay, let's continue. So with stairs, we have the same issue, and for the stairs I will reload this one, and I have my stairs here. And for the stairs I have calculated or created this object which represents the closed polyline, and from here I can see I have area of the polyline, so I don't need to have a hatch. I can have the polyline, and it's enough to calculate the area parameter. But in this case, this part should be moved to this location, so I need to fix, and I will hold Shift and move this part here. Okay, so maybe not this one. Nope. Okay, so maybe this one. I will move here, and I will draw extra line, snapping here, and extend, and draw a line here. And now, so these are my reference lines, and just extending this part. So now I have these elements representing the steers, and I have three objects, one steer path, another steer path, and the landing. So let's calculate quantities of the landing. So I have area in millimeters here. I will copy this information to my clipboard. Next, I have area of my steers in this location, copy. And also I have area of these steers, copy. So let's save changes, because I made some changes here, and they will be automatically saved to my main drawing. And now I can unload this reference view and calculate. So steers 1, steers 2, and steers in total. So steers 1 is steers internal, steers 2 is steers external, steers 2, and in total all the steers combining 1, 2, 3, 4, 5 elements is calculated for the steers. So let's begin calculation. So area will be one area plus another area plus landing area, and multiply it by 3 zeros and 0, 0, 1. So this will be area of internal steers, and I'll also need to add external steers. And next one, I need to multiply it by weight of the steers, 1.3 meters. And the landing is different weight. So so this number should be removed. And this is internal steers. Now the landing plus volume of the landing. Apply by 0.00001. Area of the landing, and the landing size area I have, so I need the length of the landing. So length of the landing so 30 millimeters from all the sides. Okay, so 2.9 minus 100 minus 30 minus 30. multiply 0.9 minus 0.1 minus 0.03 minus 0.03. So, okay, so this part is the landing, this part is internal path of the stairs, and also I should add additional information from external stairs, but in my drawings I don't have it, so I will leave it as it is. And yeah, so later I can add additional information. And now for internal stairs I can try to calculate the information here. So it should be 2.65, 2.57, Okay, so I'm checking additionally. I calculated all the information. It should be correct. In my case, it's too much volume for my internal stairs, and external stairs is 0.48. So I will just type the number 48. And for total stairs volume plus 0.48. So let's check where can be the mistake. So let's reload. So the distance 1.3 and it's 1.6. So let's measure. Distance to my wall is 1470. 1470. Okay, it's correct. So this part is calculated correctly. This part is also correctly calculated. Two hundred, okay. 150, okay. Mhm. 1.3 meters. So 1.3 meters should be to this position. It means I need to move this part of my stairs to this location. One 1.5 meters. Okay. One 1.47. Okay. So this goes here. Yeah, so I have this mm, so this part is inside, so my landing geometry is a little bit different. Not fully the same size. So for the landing, I should take dimensions and the size maybe from schematic view. So you can see I need to minus this part, so one step from this location and additional gap here, so this part should be minus from the landing. Okay, let's save changes. Unload this one. So my landing is here, so I need to I have an area, I have the length. So additionally, okay, so this is this one, this is landing. So I need to minus, so 0.2 for thickness, multiply by by 1.3 and multiply by 0.3 for the step, and additionally to this one I need to add here additional formula, so plus 2.9 minus 0.1 minus 1.3 minus 1.3 and minus 0.03 minus 0.03. Okay, 2.6. Yeah. I will recalculate this area. So let's try a different approach. This is length of one side. So I will multiply by 0.2 thickness, multiply by 1.3 and 2.9. Okay, and I need to put minus here, copy the same formula, and regarding the length, minus 1.3 meters, multiply by 0.2, multiply by 0.3. Okay, let's see what will happen. Yes, 2.56, 2.57. So minor mistake. Yeah, manual calculation maybe made some mistake in some assumptions, but I got needed number here. And stairs, total stairs 3.04. Yeah, 3.04. So now the stairs are fixed and I need to calculate the walls. So regarding walls, I have the same situation, similar to foundation. So I can do calculations. So I have two internal walls and 12 external walls. So let's try to calculate it. So first I want to measure the size of my walls. So the height of my walls, from here I can see from 850 minus 200. So I have the thickness of foundation walls, 0.850 minus 0.2, plus I have 3 meters here, minus thickness of the floor, plus 3 meters minus 0.2, and I have additional 5 meters, so 2 meters wall here, and additional wall part here. So to calculate this part, it's, I think, best to use hatch calculation. So for this part, I calculated the height of first floor and foundation walls, and let's multiply by 0.2 thickness of the walls and multiply by the perimeter of the walls. So perimeter of the walls is 3.0 plus 4.2 plus 6.0 plus 6.0 plus 3.0 plus 4.2. Now we have this information, and so total volume of my first floor and foundation floor. Now from all this I need to minus size of the doors and size of the windows. So the doors size is 2.1 multiplied by 0.2 and multiply by 1.2, and regarding windows, so windows 1.0 multiplied by 0.2 and multiply by size of the window is 1.2 meters, 1.2, and another window is 1.5 meters, 1.5 meters multiplied by 0.2 multiplied by 1.2. So this is the volume of first floor and foundation floor. Now internal walls, let's calculate this part, equals so 0.2 thickness multiplied by 3 meters minus 0.2 and plus 0.85 minus 0.2 and multiply by length. So the length will be 0.32 plus 0.9 plus 1.48 and plus just 48. So this is volume of walls internal, and I need to minus the volume of the doors. So 0.9 multiplied by 2.1 multiplied by 0.2. So it should be 1.49. And from here, let's see, 1.49. Yes, great. And now I need to calculate second floor volume. So it's quite a tricky part. So I can calculate 2 walls here, and I need the area of this part. So so to do that, let's reload. So polyline, and I will use different technique now. I will just draw polyline on top of my reference view. So this will be area of my facade walls. And now I want to calculate area of this part. So I will use polyline again. And in this case, I think calculation should start from this part. Okay, so I have 2 numbers here. So let's unload this part. And now here, let's add additional information. So I need to add additional volume. So first, let's add volume of these 2 walls, multiply by 0.000001, multiply by 2. I have 2 walls, and multiply by 0.2, and plus another area. No, I don't need to multiply by thickness because I have area, so I need just the length. So the length will be, my length will be, in this case, 3 plus 4.2. Length will be 3.0 plus 4.2. And in our case, I have area of this one multiplied by 0.30001 and multiply by thickness. In this case, I need thickness and multiply by 2 because I have 2 walls. And let's check what will happen. So 30, 38, 30, 36. So 0.02 cubic meters too much. So I think the problem is in this allocation because I created this part here. So I will try to change information here and change this part Okay, so I make assumptions. So this wall goes through all the part of the building, and I need this column. So I will replace this one. And now instead of 3.0 and 4.2, I will have 7.4 meters, all the length of my walls. And let's check what will happen. The same 0.38. Mm. 7.4. So this is length of this wall, and this is length of this wall. And this is parts of these two walls. So formula is quite big, and to identify the mistake, it's complicated now. Perimeter. Maybe I made mistake here with calculating the perimeter of the wall. 4.66. In this case, I would like to check maybe additional information. 3D model to identify and to see what are the size of or the volume of each element. But now, yeah, so I have some mistake here. In any case, here is the concept how all these calculations works, and yeah, you need to be quite precise to calculate all the parameters. And now I have the total quantity. So the total quantity is 78.3637. So 0.1 cubic meter is more. It's good, it's not less, but in any case, the number should be precise. So for the concrete price, if I look here, so if I open prices of concrete, for example, in this Lithuanian manufacturer, let's change it to translate to English. And concrete for flooring stand, concrete for stairs, concrete for foundation, including what? Concrete for foundation, concrete for overall standard. So the price is 117 euros, including that. And here we have additional specific details. So maybe this class should be used. So I can add additional information for my schedule. So in this zone, I can add additional details. So the link to this web page, and also I can calculate the total price. So change this data also to specific model. So specific model is this one. So let's change it to C3037. And for example, the price will be, I can use formula for F17 multiplied by price per 1 cubic meter, 133. Point M. So let's change this part to current units, decimal, 2 digits, and in this case it should be currency. And for the currency, custom table sale format. It doesn't allow me to change to the currency. So let's turn off data here, change information here. Now decimal number. It doesn't allow me to set the currency, current units. Decimal, precision 2 digits. And I will put suffix here and use character map and add currency information. So I need euros symbol, and here I have euro symbol. Copy. So the price of my building, concrete, it will be about 10,000 euros. So calculation. So the mistake of my calculations, how much it costs, 0.1 multiplied by 133.01. So it's 1.3 euros of the mistake. Yeah, so the mistake is not so large, but as I mentioned, our building is small. So if you are doing the same mistake for large building, multi-story building or skyscraper, so this price can exceed €1 and can become 1 million euros. So in engineering graphics, in engineering, all the numbers, all the data should be as precise as possible. So now this is my reference view, so I don't need it, so I can save this information, close this schedule, and now I can go to the sheets part, create concrete schedule, detach this information, go to model space, remove all this information, attach the schedule which I created. So schedule is attached, and now I go to layout and insert view, and I have specific view size of my schedule, and I can place it here, and the scale is 1:1, and I use move tool and change position. And here's my schedule inside my page, inside the sheet. So I just need to change information here, building project title, and building number and title and document. So in this case, instead of my group, I should type building number, so it will be schedule and building number. In our case, it's the name of our project. And yeah, so the code can be this one. So building number. Let's use homework number 4 for the building number, and document marking should be this one. So A05. And let's press enter and put it here. So document marking, I have the project code, I have your group name, homework number 4, name, surname, and the specific number of my project. Here I should change to Vilnius Tech. Name, surname, student ID number, and building project title. So building project title I can take from Planary. So in the Planary I have all the basic information about my project. So the project name, brief description of the project name, project owner. So I can use this one. So our building number represents our homework. Here I have the title of the document, concrete schedule. And here I should change the data. So it's 25, 12, 14. And time is not needed, just the date. And now let's check if everything works fine. Let's print it. In this case, I will use the Vilnius Tech template and we'll use, let's say, black and white. Review. Everything looks okay. And let's print it. And I will save it now inside Sheets and leave only this name and plans, details, and inside Sheets I can add additional sheet, schedules, save. And here you have nice looking drawing created. So maybe the size of my layout has some issues. I need to maybe double check this part because I am using maybe the wrong layer here. So for my I will use just continuous line here. And let's use previous plot and click OK and save it on top. Please specify another name. Yeah, I need to close. Okay, let's try again. Do you want to overwrite? Yes, I want to overwrite. Now it looks much better. Additional option how to fix this issue, I can change the order and send it to back. So in front I have my main line. If I turn on thickness, so my frame line is in front of my view, and in this case it will print correctly. Also, I don't have any nodes here, so I can delete the nodes part and print again. So a couple of iterations till I see if my drawing is correctly printed, and after that I can confirm what I got the correct results. All the data is nicely set, all the information is visible, so final drawing is correct. And now I can move this drawing inside publish folder. So now from my sheets folder, schedules, I can copy it and go to project files, published, architecture, homework number 4, and place it here. And I have a final drawing prepared, and I can create and collect all other parts of the drawing and submit results for the grading. So schedule part is done. Same part I should do for my details view. So callouts and details. And detach this part. Turn off these extra dimensions. I will not need nodes. In the model space, I will delete all these elements and will insert attach 0401. And now in here, I will use layouts, insert. On layout. And additional one. And now I should also check yeah, so page object. So scale of this one is 1 to 5, and scale of this one is 1 to 10. Of course, we have a lot of space here, empty space. It's not efficient to use maybe such large page for this information. Maybe I can organize and place everything to one A4 file format. It's possible, but in our case, let's leave as it is. And now I want to check size of these break lines. So I see the size of break line in this case is too small because I made wrong assumptions last time, and the size of this one should be double size. So I need to fix this mistake. So I go to the model space from my sheet, and I will use edit reference in place and scale 2 times. No, maybe 2 times it's too much. So it's 25, it should be 50. So my break line should be Yeah, double. So the size should be 100 and extensions should be 50. Yeah, so correct size should be like this one. And the same goes here, brick line. Match properties. And let's trim. Allow me to trim. So let's try to pick points. I will add this point and remove this. And remove, yeah, this part. A closed bond cannot be determined. Okay, so we have some issues here. Redraw, regenerate, and okay, so let's escape, region all, and let's try to trim again. Select object to trim or shift to extend. So I will use shift and just change position of these hatch boundaries, and I will solve this problem like this one. So I'm not sure why, but trimming is not working. So I'm just changing the boundaries of the hatch manually. Okay, this part is done, so I will match the properties, save changes, and automatically my reference drawing view drawing is updated, and I have all the dimensions same, so the size and proportion should be the same because scale is different. Now I need to insert and put annotation. So in this location, I need to add title name. So the title name. So in this case, call out. Scale will be 1 to 10. And call out goes to I think maybe general. Okay, I will double check this view. So general title block outline. Okay, title block outline. So general title block outline, and in middle and in middle center. So title name should be approximately in the middle of the view. The same goes here. Detail and my detail. So this is wall T1, wall T1, wall T1, and I need to fix parameters here, and the scale of this one is 1 to 5. So I need to go here and edit references. Wall T1, and the same goes here. And also this one should be changed. So according to this view, this is ROT1, roof 1. I will change and save view, and automatically I updated my view, and inside the sheet also information is updated, and change all these details same as I showed before. And now let's print it. And I will use color mode. And the hatch scale is in here too small, I think, so I need to change and adapt the scale of my hatching. So from the preview, hatch is not correct. So the scale of this hatch should be annotative, and should be 10, I think. Scale, annotative. I have 1 to 1, and I should add 1 to 10. And the same for this one. And 1 to 10. Okay. And for this wall, it should be scale 1 to 5. Add. And for this dimension, somehow this background fill color, so fill color background, let's change it to background. Okay, and save changes, and let's see in the drawing. Yes, now scale has been correctly assigned, and yep, now let's print again. Layout, preview. Now it looks great. And I can click OK. So details 0.4. Save. And here I have nice looking drawing. The dimensions, layers, title names. And it can be uploaded to publish and also added to the final submission. Okay, so shadows and details and callouts part is finished. So I explained all the parts of our project example. So how to do facade view, plan view, details and shadows and sections, and how to create and organize all the drawings. So if you have any questions, leave some comments or write in our Teams group, and I will provide additional support for you. So thank you for your attention. Till next time. Bye.